So boiling point increases with chain length. So chain grows by 1 carbon at each time. Family can be described, So alkanes found in oil and natural gas. Natural gas mostly methane with small amounts of ethane, propane and butane. The mixture of compounds in oil includes the alkanes with chains of up to 50 carbon atoms. Longest chain, we've already done that. Each carbon atom forms 4 single covalent bonds in an alkane molecule. Alkanes burn well with a good supply of oxygen, forming carbon dioxide and water vapour, giving out plenty of heat, so they're used for fuels. For example, methane is CH4 gas plus 2 oxygen gas makes carbon dioxide gas and 2 water H2O liquid plus heat. But if there isn't enough air, they undergo incomplete combustion where they burn, producing carbon monoxide and soot, giving out less heat. Alkanes also react with chlorine and bromine, for example, methane plus Cl2. The reaction has to include light, makes chloromethane, which is a C, I'll just show the thing, plus hydrochloric acid. Not sure if it's focusing well. The rightmost side is a chlorine atom. So it's called a substitution reaction. So it forms tetrachloromethane, which is CCl4. So substitution reaction continues until all the hydrogen atoms have been replaced by chlorine, giving tetrachloromethane, which is CCl4. Boiling point and chain length. When a liquid boils to form a gas, its molecules separate. You supply energy for this by heating. Longer the chains in hydrocarbon molecules, the stronger they are attracted to each other. The more stronger they are attracted to each other, the more heat and energy is needed to separate them. So the longer the chains, the higher the boiling point will be. Isomers. So, yeah, they're quite a pain to do. So, as molecule change gets longer, the force of attraction between them increases. So, here they've got the same formula. So, butane and 2-methylpropane. Both the formulas C4H10, but they have different structures, which means 2 compounds different. They're isomers. Isomers are compound with the same formula but different structures. More carbon atom in a strain, the more isomers there'll be. There are 75 isomers of the formula C10H22. Properties of isomers. Since isomers have different structures, they also have slightly different properties. For example, branched chain alkanes have lower boiling points than straight chain alkanes. The branches make it more difficult for the molecules to get close and attract to each other, burn less readily in oxygen, so more useful in petrol. Boiling points of isomers, so C4H10, C5H12. So C4H10, straight chain is boiling point is 0, branch chain is -10. Straight chain is 36, branch chain is 28 and 9.5, depending on the structure of it. Reactions of alkanes. Alkanes are usually... the chains are shorter the lower the boiling point, despite the same formula. Therefore easy to boil and they have more branches. As they have more branches, so they're isomers. Reaction of alkanes. Alkanes are usually described as being unreactive, but there are 2 reactions they can undergo. Combustion and cracking. Combustion is the reaction of fuel with oxygen. Heat energy is released, so it's exothermic. For example, methane plus oxygen makes carbon dioxide plus water, or CH4 plus 2O2 makes CO2 plus 2H2O. So energy graph for methane and oxygen. Just study all this. two types of energy present: thermal energy and chemical potential energy. So, thermal energy, chemical energy is transferred to thermal energy, released after reaction to surroundings. Chemical energy is in endothermic bonds. Chemical potential energy transferred to thermal energy, so definition of exothermic. So products of combustion, you might have to study that diagram, there's quite a few diagrams on this topic. When the candle or fuel burns in oxygen, the pump pulls the gases that form onto the U-shape tube. Water vapour is condensed to liquid water. The cobalt chloride paper turns from blue to pink. Test tube lime water turns milky. So you need to know this. Energy in kilojoules in bonds. Carbon-carbon single bond is 350. Carbon-hydrogen is 410, single bond. Carbon double bond oxygen is 805. O to H, single bond is 460. Double bond oxygen is 496. So you can find basically the amount of energy is, so how much energy is required to break the bonds of reactions. So you do all the energy in the reactants, and how much energy is released when new bonds form in the products. So you just got to do it of the products. Calculate the products. So if the reactants energy is greater than the product's energy, it's endothermic, and if reactants energy is less than the product's energy, it's exothermic. So the description will be the energy required to break the bonds in the reactants less than the energy release when the new bonds form in the products. So exothermic releases heat energy, endothermic absorbs heat energy. Using a laboratory apparatus, how can we tell? Thermometer would be used. It would show an increase in temperature, which is exothermic. So combustion of butane, C4H10 plus 13 over 2 O2 makes 4 CO2 plus 5 H2O. Yeah, so it's just simple things there. Here's another. So yeah, neutralization and combustion are exothermic. Endothermic. Endothermic is neutralization of ethanoic acid with sodium carbonate. Barium hydroxide with ammonium chloride. Temperature falls. So the time the reactions take. So endothermic is reactants plus heat energy makes products. Heat energy is transferred from the surroundings. Energy level diagram. The overall, neutralization and combustion are exothermic reactions, but neutralization of nitric acid with sodium carbonate is endothermic. If overall a reaction takes an energy, it means products have more energy than reactants. You can show it on an energy level diagram. The reactants must climb a gap for the reaction to go ahead. They steal energy from the surroundings. Endothermic reactions, so they occur spontaneously when you mix chemicals. There are many other endothermic reactions. Energy must be supplied to start and keep the reaction going. For example, cooking, polymerization of ethene to polyethene, photosynthesis, and electrolysis. So, iron and sulfur is exothermic. Silver nitrate and sodium chloride, white precipitate, exothermic. Water to quicklime or calcium oxide, heat given out, temperature rise, so exothermic. So reactants to Arrow products plus heat energy is exothermic. If overall the reaction gives out, study those diagrams, more it gives out energy, it means products have less energy in the reactants. You can show the energy level diagram. And here are some of the energy level diagrams. So boiling points, high boiling points collect nearer to the bottom fractionated column. These are less useful because they don't burn very well, so do not make good fuels. Cracking is a process used to break these large hydrocarbons into small molecules so we can use them as fuels. Here's some more energy level diagrams. Sodium plus water makes sodium hydroxide plus hydrogen, so these are neutralization, combustion. Iron plus sulfur, calcium oxide plus water makes calcium hydroxide, so these are all exothermic. Burning a candle, igniting and firing gases, respiration. So endothermic barium hydroxide reacting with ammonium chloride gives off methane plus oxygen, carbon dioxide and water. Thermal decomposition, cracking, acid plus hydrogen carbonate gives limestone, citric acid plus sodium hydrocarbonate. So cooking or endothermic. Cracking, small alkanes, lower boiling points, runny, easy to ignite, burns with clean flame, boiling point, So big alkanes, high boiling points, viscous, hard to ignite, burns a smoky flame. So the trends are as the chains increase, boiling points increase, viscosity increases, flammability decreases, flame gets dirtier. Cracking. Oh, look at this, bloody hell. Cracking, you just have to study this diagram. So it requires a high temperature and a catalyst of zeolite, and it's so cracking is where long alkane chains which are hard to burn and not used for fuels very often, are broken to short chain alkanes, significantly high in demand and supply, and useful for fuels. Cracking diagram. Hazard of cracking. When the heat is removed, the pressure starts to decrease and water will be sucked back into the tube. The boiling tube is very hot and the water is relatively cold, so the boiling tube will shatter. Prevention. Remove tube 2 before you remove the heat. Just quickly study that. Some of the cracking examples. Climate changes the insulation of thermal energy from the sun by greenhouse gases instead of being mostly radiated out in space, and can affect the climate. Definition. Saturated. Molecules only contain single bonds or no double bonds. Unsaturated molecules contain double bonds. Hydrocarbon, a compound comprised of hydrogen and carbon molecules only. Homologous series, a family of compounds of same general formula and similar chemical properties. Alkanes are a homologous series of saturated hydrocarbons, general formula CnH2n+1. Here. some MEPB, meth, eth, prop, bute, 1, 2, 3, 4 carbon. Just easy to remember. Stuck it in the wrong way round. I'll continue with this next.